multiple reasons on that. And then, oh yeah, one class didn't even do it. That was why. One class didn't even try with that. So that's why. Good question. Okay, while y'all are over there, are y'all good if I just go ahead and start and we'll just kind of eat and food makes everything better, doesn't it? Everything better. I'm going to say one thing. I made up this thing at home. I don't know why I'm saying this. Called smash corn. I made this up. Okay. All right. You got to think with me. How many of you like popcorn? You like popcorn? How many of you like sweet salty? Like the sweet salty? Okay. So you know those little Hershey drops, like the cookies and cream Hershey drops? Okay. Think about this. I made this up. I think I'd heard about this, but I made it up too. I took a bag of popcorn, put it in the microwave. Right when it's done, take those Hershey drops, like 7 of them, stick them in the hot popcorn, shake it up, okay? Let it sit for a little while, and the Hershey drop just, y'all, the best thing ever in the world. Smash corn, made it up. So, good, really good. If you've never tried it, tell me, try it. What's that? So you take a thing of popcorn. It's literally the best thing I've eaten. Take a thing of popcorn, whatever, put it in the microwave, let it heat up. Right when you take it out, because you want them to melt, like all throughout the popcorn, you take like 7 or 8 Hershey drops. If you want more, if you like chocolate more, put them in.
Hershey Kisses.
Well, you could do that. I did their Hershey drops, they're like circles, and I do the cookies and cream because I like white chocolate, and I throw them in there, and you just shake it up. And you let it melt all the way through, you let it go, and it's like a surprise inside. You like eat it. Oh, dang. Made my day. Don't know why I said that, but just it's one of my favorite snoochers in the world. Favorite snoochers. Okay, synthetic division. Hey, I started with this mainly because this is usually the easier of the two options. I would say this. Go to the synthetic route unless you can, okay? So let me say that again. Do synthetic unless I can, all right? And by the way, if you want to, go ahead and get up. If you have not gotten food, go ahead and get some. As we start on the first one off the homework, notice that this polynomial here has a degree of what? We'll start there. What does it have a degree of? 3. Good, Thomas. Someone else help me. In fact, Kill, what's the lead coefficient here? 5, very good. So what we're going to do on this is take the polynomial, and we're going to write it in order, okay? If it's not in order, you've got to put it in order, okay? So what I'm going to do is I'm going to put just the coefficients, so 5, 18, 7, and negative 6, all right? So 5, 18, 7, and negative 6, okay? All right, so those are the coefficients. Then I go to my magic box. The magic box up in the top left corner, and that will always be the number that sets x plus 3 equal to 0, okay? So what number would x be equal to here? Negative 3, good. Okay, so we got negative 3 there, and that's really what we use for all of these coefficients as we simplify this, okay? Now, in dividing this, we then do what with that first 5? Yep, bring her down. Okay?
Is there coffee?
I don't know if I do have coffee there. That would be sweet. That would be a good combination, though. Taking down 5, that's the first part. We then multiply 5 times what? Yeah, now this is where we bring in the negative 3, okay? So negative 3 times 5 gives me negative 15. We then add down. We add down to get us the value of 3, okay? Now keep going. A lot of you know this pattern. What would I do next? Good, to get us what? Good. What do I do next, Zar? Good. Gets us? Good. Negative 2. And then negative 2 times negative 3 gets us?
6.
Positive 6, which when added gets us what? 0. Okay? Now, there's a lot of stuff I'm going to hit on right now, okay? If you get it in this moment, it's going to help you as we progress forward. If you don't quite get it, we're going to hit on this again and again, okay? Now, remember, this was x to the third, x squared, x, and then just the coefficient by itself, okay? When we do this, though, when we divide, I always start from right to left, okay? So the furthest right number is our remainder, okay? The number that's left over. The value that's next, that -2, is just our coefficient. It's the number that goes by itself. The 3, does anyone know what goes with that one? An x, very good, Caitlin. And then 5 has what? X squared, right? And then if there was another number, it would be x to the third, and so on and so forth, okay? So let me say that again. Remainder, the number that's by itself, x squared, and then x to the third, and x to the fourth, and so on and so forth, if we had one, okay? So when we divided by x plus 3, we would get an answer of 5x squared plus 3x minus 2 with a remainder of 0, okay? Very good. Questions off that? How many of you remember that? Yeah? Anybody not remember it? Just so I can kind of, some of you probably have seen it before. You just need to be reminded on the pattern. But yeah, that's where we're at. Can someone tell me for 8 tickets, when the remainder is 0, it tells me something about the polynomial, something very important about the polynomial. Josh, do you know what it tells me? That this right here, the way that I approach this, if I get a remainder of 0, that's very significant to the polynomial.
What would you do if you do have a remainder?
If I had a remainder, go ahead. I'll give you 2 tickets if you could tell me. Let's say I had a 2 as a remainder. What would I do with that 2?
You put it to the right, you put 2 over x plus 3.
Yep, you just say plus 2 over x plus 3. Okay?
Tell you
It
it doesn't work.
doesn't work? Not quite. That's a good thought process. I like that thought process. Caitlin, do you know?
Does it say that -3 is 0?
Bingo. Yes. Okay? Let me say that, or let's say that again. I like what Caitlin said. Did I say 8 tickets? I think I did. Look at that. Yeah. When we have a remainder of 0, it tells me that it is an x-intercept. Okay? So what does that mean? That means in this polynomial, if I get a remainder of 0, that means -3, that the graph is actually going to hit -3. Cool? If it's anything other than 0, that means it is not a x-intercept or a 0 that's there. It will not hit the x-intercept at that point. Okay? That also tells me that in this polynomial here, x plus 3 is actually a factor of this. Okay? Does that make sense? All right, I'll give you 8 tickets if you can tell me, other than Caitlin. Someone could tell me this. And if no one else can, I might come back to you, Caitlin. What can I do to find the other zeros of the polynomial? We're going deep. I didn't plan on doing this. We're going deep. We'll come back to it. Zaria, what would we do now? Quadratic to what? Yeah, what's the answer again? Perfect. Anybody else have another thought on what we could do as well? Great job. Yeah. Exactly right. You could use this part, right? This part to factor and then solve for the remaining solutions, right?
Plug in, since you know that's the answer, you plug that in.
Say it one more time again.
Since you know
Josh.
that 3 or -3 is a answer, you can plug that in.
To here?
Or
Not-
no,
Quite, because this is not the polynomial. It was really this. So we've actually taken -3 out because this is the simplified version, right? So we can use quadratic. There's another thing we can do to also solve this. Factor, that's it. Yeah, that's exactly right. And so that's what we would be looking at in terms of solving for the remaining solutions. Did I take it too far here? I kind of went further than what I was going to. Did that make sense? Remainder of 0 tells me it is an x-intercept or 0. We'll hit on that further when we go. Big thing is, how do I use synthetic division? Look at the second one, which is a homework one here. It tells me that we have this 10x to the fourth, 50x to the third, and then -800. Emma, do you see something that's different from the second to the first?
Oh, it doesn't have like an x squared or an x.
Yeah, no x squared or x there. And so, what would I do, you know?
Just plug in a 0 for, well, not plug in, but when you're like writing it out, synthetic division, just put a 0.
Great job. Yeah, because we've got to fill in each of those spots, right? Great work. So we would say 10 -50 And then for x squared, we would put a what?
0.
0, good. For x, we would put a
0.
0, good. And then negative 800 would just be what we would have out here, okay? Cool. What would I put in here? Positive or negative 6? Positive 6, yeah, positive 6. And then we would go ahead and attack that, right? We'd go ahead and attack it. What'd y'all get down? Well, let's just go through the process one more time just for those that need it. What would I do with the first one? Bring her down. All right. What do I do now?
Multiply and then combine 50.
Yep, so 10 times 6,
Yeah.
we get 60. Combine, we get
10,
10. Keep going, Thomas, you're good.
60,
10 times 6 is 60. We add here to get
0, or 60,
60. 60 times 6 is
3,600.
I think 60.
Oh, wait, yeah. 360.
360, good. We combine here to get
0,
360. This is too hard. 6 times 360 is 2,160. What's that? What was that? I think it's that. Did you say something, Josh? You could have been right. I don't know. What did you say? I was just curious.
I was thinking 800.
Oh, you did what? You thought it would match up, kind of even. Is it? What was it?
2,860.
Yes, that's exactly right. Oh, I thought you had a does someone have a calculator at all? 2,160. You were close, right? 2,160 there. And then we add together, and what do we get? Someone subtract 800 from it. Say that again, Rick. 1,360, okay? All right, so question. This is a remainder, right? Okay? What is the next number? What is the next number that we have? No x, good. And then we keep going, right? So we have by itself, x squared, and x to the third, right?
Don't need to do it again.
We don't have to in this case. We actually can't in this
This
instance
is a remainder.
because there's a remainder. So what do we know about x minus 6? And Josh was saying you were thinking that it was a 0, right? But in this instance, it's not. So guess what? X minus 6 or 6 is not a 0 of that polynomial. Why? Because there's a remainder. Good. So I would just say 10x to the third plus 10x squared plus 60x plus 360. And Josh, what do I do with that remainder again? Yeah, there you go. 1360 over x minus 6. Boom. That's it. Okay? That's our synthetic division and simplifying that polynomial there. Okay? How do we feel about, go ahead. You have something there, Elijah? Over x minus 6. It's a good question. And the reason why it's x minus 6 and why Josh did it was because of the what's below. Does that make sense? So like whatever's the remainder, we put it over what we divided by. Okay? Cool. Did I give you tickets for that? I think I did. Do I? Did I put them down there? I have no idea why. Just make sure I know, it's mine.
Yours.
Yeah. Just in
You can
case.
tell by
Just in case.
it.
All right, questions off this? Synthetic, can we just check that off? We're good? All right, the last thing before we complete part 1 of this lesson, okay? We went through quite a bit, believe it or not, through that part there, okay? It's the dreaded long division, okay? Yes, you remember this. This is usually where kids cuss in my class, okay? So please refrain, all right? You got me? Refrain from that. Savannah, I'm concerned, okay? All right. As we go through this, though, I would just say, again, the process, it's all about the process, okay? Synthetic, I feel pretty good about. That's why we did it first, and that's why we got 2 homework ones done. The long division one is the one I'm concerned with in terms of making sure we understand it. Remember I said use synthetic unless we can't, okay? Does anyone know when we cannot use synthetic division? Yes, this is true. When it says use long division, that is definitely true. Definitely true. Does anyone else know? All right, let me show you. This right here, when we go to the long division side, and I think we've already done this, right?
There's an X in
I think you're onto something. Look at number 4, okay? Look at number 4. As we look at number 4, can we use synthetic division there? Yes, we can. Look and see at x plus 2. Can I set that equal to 0 and solve for what x is equal to? Yeah, because there's only x plus 2, right? Emma, do you have an idea? Go ahead, yeah.
When there's like an exponent, when what you're dividing by, or if there's like a coefficient.
You said that perfectly. So if I have x squared, or anything greater than x squared, I can't use synthetic. So look right now on number 5. Can I use synthetic here? Yes, I can, because it's x plus 2, right? Set it equal to 0. My magic box is -2, and you're good. Okay? You're Gucci. Number 6, can I? I actually can. Because 2x plus 1. If I set 2x plus 1 equal to 0, what would x be equal to?
1/2.
X is equal to -1/2, and you would put in your magic box -1/2, okay? Now here's where the frustration comes. Look at the next one. 2x squared plus 1. That's different, right? It's not just x plus 2 anymore. We have something that is squared. When that happens, you can't use synthetic. You've got to use long division, okay? Sound good? So what we're going to do is we're just going to rep out 1 or 2 of these and make sure you understand the process, okay? All right, let's do this. Let's do number 7, okay? If you've got the notes, I think it's on the notes. If you don't have it on the notes, I might just put it on either the back of the homework, or you could maybe put it on a separate sheet as well, or maybe just listen, depending on how you learn there. Okay, so with this one, you set it up like a long division problem. So on number 7, I can just put 6x to the 3rd plus 10x squared plus x plus 8. And I forgot who said this. I think it was, might have been Emma. I could be making this up. But someone said, if I miss an x squared, make sure you fill it in with a 0. I think you did say that, Emma. So because of that, this does not have anything we have to fill in, so we just keep it as is. Okay? Now, what do I divide this by? Well, it's going to be 2x squared plus 1, right? But I've also got to fill something in here. What do I need to fill in? The x. Just like I did inside, I've got to do that on the outside as well. So I'll have 2x squared plus 0x plus 1. Okay?
What if there's no, like if 8 wasn't
Yeah, right here, this side.
there?
Yeah, we'll put that in with a 0 as well.
If
Good
there was
question.
nothing, if nothing was there.
Correct. Mainly because we want to make sure each part is filled. Okay? All right. I know I'm going to keep asking this because I know this is a struggle area in past years. Any questions on how I've set this up? We're good? Okay. Here's the one thing to remember. When I look at what multiplies to what, we only look at the first and the first. Okay? Now you've got to get the pattern. It's the same as when you long divided when you were in elementary school. Same process. We ask the question, what do I put up on top that multiplies by 2x squared that gets me to 6x to the 3rd? Very good. Yeah, good, Caitlin. So we say, first of all, let's talk about the 2 and 6. What times 2 equals 6? 3, right? What times x squared equals, x to the 3rd? X. Okay? Nicely done. Who is that? Was that Kennedy?
What if it wasn't, you couldn't multiply into, say it was 3 and 5.
Like 3x to the 5th? That's a good question. I would say I probably won't be that mean. I'm not saying I won't ever. Is there one like that on there? There is. What's on the outside? Is it 2x squared? That's on the outside.
It's x cubed and then x
On the inside. Gotcha. I will do this. Can we do that one next? Maybe we can look at that one together. Because that might be the same process, but maybe a different in the way that we go after that. Good question, though. So what would it be in terms of this? Well, we said, just like Kennedy and Caitlin helped us with, it would be 3x. So the way that I write this is I always keep my x's on the same line, and x squared here, and x to the third here. That way I know, like, okay, that's where I'm focused in on. So we're just going to put 3x right above this x here, okay? Now, just like normal division, when I get a value here, what do I do once I get this value? I multiply it to whatever the outside is, right? But there's 3 different parts, so I've got to multiply to each part. So it'll be 3x times 2x squared to get,
Where'd you get 3?
right here, this came from what multiplies by 2x squared to get to 6x to the third, right? Well, the 3 is easy. What times 2 equals 6? That's 3, right? But what in terms of x times x squared gets me x to the third? That's just 1x, right? So that's how I got 3x there. And then the 3x, we multiply to each of these 3, right? So 3x times 6x squared should be 6x to the third. If that's not the same, I did something wrong, okay? I did something wrong. I need to go back and check that, okay? 3x times 0x is 0x squared. Am I confusing right now? We're okay? Okay, just making sure we got the pulse here. 3x times 3 is, or 3x times 1 is? 3x, good. And then what do I do here? Change the sign, combine. Boom, boom. Okay, what do I do now? Combine it, good. Gone like a freight train. Okay. Good, yeah, so then I go down, so we got 10x squared on this part here. And x minus 3x is minus 2x, and then I bring down the 8, okay? All right. The 3x from the top was when we went over here, Kennedy, if you look at the 2 white circles that I put there, what times 2x squared gets me this one here?
That's the same thing.
Yes, so once I got 3x, right, I have to distribute or multiply by each part. 3x times 2x squared is 6x to the third. 3x times 0x is 0x squared. 3x times 1 is 3x. And then I change the signs. Cool? All right, so what do I do now? Here's the hint. I do the same process again. Same thing. So then I say, same thing, except now it's not 6x to the third. What times 2x squared gets me 10x squared? 5. Good. Yeah, so only 5 would be that number, right? So I'm going to put plus 5 on the outside over top of that 8. Keep everything in order. And then I multiply 5 to each parts of this, right? So 5 times 2x squared is 10x squared. 5 times 0x is 0x. And 5 times 1 gets me 5. Good. What do I do now? Change the sign of each of these and combine. And then what happens on this part? This cancels. Negative 2x minus 0x is just negative 2x, right? And then plus 3. Is it minus 3? Plus 3, right? And then I get this here. Is there anything else I can bring down? I don't think so, right? So question, what times 2x squared gets me negative 2x? Yeah, I saw that, Kayla. There's nothing, right? There's nothing I can do to say what multiplied by 2x squared gets me to negative 2x, right? That's when I know that this is my remainder. Good. So how I would write this would be 3x plus 5, and then what happens with negative 2x plus 3?
Plus that, what you just said, over
Mm-hmm.
2x squared plus 1.
Nice. Good job, Ken. Good work there. And that would be my answer. Okay? Questions off that? I like synthetic better, don't you? A little bit. This is one that may take a little bit of time. Okay? Here's what I want you to try real quick. If you go to, see if I've got the red, was that on 2.3a? That one that we were talking about? Number 1, right here. Perfect. Let's do that one. We'll practice this one, and then we'll take a little bit of a breather here. Cool. All right, let's talk it through. Let's see if we can do it. What goes on the inside? 0x to the fourth plus 0x to the third plus 0x squared plus 0x, oh my, and plus 7, right? Good. Grant.
Yeah,
Celeste, what, was that you?
definitely Celeste.
Celeste. Good night. All right, does that make sense though? Filling in the zeros, right? Just filling in zeros with each of the exponents. What goes on the outside, Grant?
You're gonna put the other one, the x3 minus 1. We're not gonna put it.
You're right. And what would we fill in with that?
You need to fill in 2x. 2x's with zeros.
Good. So 0x squared plus 0x minus 1?
Yeah.
We are. Pretty cool. All right, questions so far? These make me happy. Do they make you happy? No, not long division. I hear you. What do I do next? What's the question?
First two.
You okay over here?
There's something else sometime I threw out.
You do? I've got mints up there. If you want one.
Thank you. I'm going to contemplate.
Gotcha. What times x cubed gets me? X to the fifth, right? What times x to the third gets me x to the fifth, and you all said it. It would be x squared. Good. And we're going to put it right over top. So what do we do now? Distribute to each part, right? So x squared times x to the third is x to the fifth. 0 was at 0x to the fourth. 0x to the third.
We have to put 0.
Hold up. You want me to hold up for a second?
So you're not trying to multiply the exponents to get to the x to the fifth. You're just adding.
Correct. So when we have something like this, right, when we have just rule of exponents, x squared times x squared, like I'll multiply them, we actually add the exponents in that instance.
Oh, yeah.
No, you're good. We haven't used it in a while, so it's easy to forget that. Does it make sense how I distribute it too?
We have to
On
put 0
that?
there.
Say again?
We have to put 0 there.
I do just to fill it in. If you skip it, don't put anything, that's okay. I do just so that I keep filling in each part. So that once I get x squared minus 1, I know now that that is actually a value of negative x squared, right? Like we can actually put that down. So once I change these signs, right, change all the signs to combine, we get what here? This should cancel. If I didn't, what happened? I messed up, right? I got to go back to my original. This would be 0 because 0 and 0. Same thing here. And then what about this last one? Yeah, and I think I changed it to a positive. That's my fault, like because it was negative. But once I change the sign, I get x squared. And what's left over?
0x and 7.
0x and then plus 7.
You just bring that down already.
I'll just bring it down. Yeah, and really, if you forgot that or if you just brought down 1, Josh, you could go and just say, okay, what's left over? Well, what times x to the third gets me x squared? Elijah, you got something? Squared times negative 1. Yes.
Yeah.
Yes, it does. Just x squared. Good question. So what times x to the third gets me x squared? Nothing, right? Yeah, I don't think. Because remember, if this exceeds down here, if I put an x over here, let's say we did do that. We forgot x times x to the third is x to the fourth, which would be greater than, right? So what I would do in this instance is say, okay, well, there's nothing that tells me x to the third times something equals x squared. So what is this? It's my remainder. Good. So we would just say x squared plus 7 over x to the third minus 1. Okay? Very good. Questions off that? The second one? How about this? If you need some help with the second one, I'll come around and help. The second one, what could I use?
Synthetic.
I could use synthetic, right? If you want to use synthetic, you can use synthetic. If you want to use long division, go ahead and use long division on that. So you kind of do you.
Is that for all of them or just that one?
The ones I cannot use or synthetic
No,
with,
no, no, wait, because it says,
It says use
use one.
it does. I'm gonna say forget that for 2. If you want to use synthetic, go ahead. If it just has an x, right? Now the key though, you can't say it's -5. I've got to set 4x plus 5 equal to 0, right? -5 fourths. Now that might be a challenge because that's going to be in my box, right? Now I could use my calculator, right? Because this is as a decimal is like -1.25, and you can feel free to use a decimal to then go ahead and your calculator to put the 4, -7, -11, and 5 up on the top here, and you can go ahead and do that. Cool. All right, I'll give you a chance. Go ahead to number 2. Just try it out. If you have need some help there, I'll come around and kind of help with that. And if you need more food or want more food, we've got a ton of it over here. Okay. Pop-Tarts, donuts, all that stuff. So, come on. Capri Suns, bringing it back. Does that make sense? They can be kind of tricky.
Number 5. What is this?
So this is called our remainder theorem. What it tells us is that if we plugged into using synthetic division in for this, you may go ahead. In for this up here, the remainder is my solution. Exactly. It's as if you plug 2 in for x in every specific situation. You don't have to. It may be shorter to do synthetic. No, you could just whatever your remainder is at the end of that synthetic division would have been your answer if you plugged it in. Does that make sense? So if I got a remainder of 0, then that means
we're just using these numbers.
in your magic box. Good. It's not some music here. Let's see here. Coming there, Tom. Yes. So if once I get multiplied out, I'd get -12x squared, right? And then and what I would do, I would change it at the very end because what I have to do is also multiply -3x times 5, right? I think that'd be -15x, right? Just don't forget the x, and you change it to 15x. Good. Yeah. Rock that. Good job. So you do multiply by 3x, exactly right. When you did that, though, -3x times 2x squared is -6x plus 3rd, and -3x times 0x is -0x squared. And then you get negative. This is perfect. However, okay, yeah, so you're right. This should actually be positive. The reason why is I want to match this down below, where it's positive 6x cubed. Before I simplify, though, I change it. Remember that? So, like, if you remember, like long division, the process of long division, like when you're in elementary school, is you multiply, but before you simplify, you have to change the sign of the bottom, right? And then you cancel it. Same idea. So this is actually, that's why it'd be 3x positive, and then that would be positive 6x to the third, positive 6x. And then change the sign. You're welcome. Yeah, sure. Exactly right. And your remainder, it's called the remainder theorem. The remainder is your solution. Yes. How about this? Just do A and C. Cool. Hey Josh, are you still on number 5 right now? Have you done A yet?
Can I go to the
Have you?
bathroom?
Yes, you may. Have you done B yet?
I'm working on it.
Just do A and B on that. So go ahead, just do A and B. Don't do C and D. If you know A and B, you're good. Does that make sense? Hey, on number 5, go ahead and circle A and B. A and B on number 5. Don't do C and D on that. That's a great question. This is called remainder theorem. Is just a fancy way of saying whatever the remainder is, when I plug 2 in for this equation for x instead of plugging it in, my remainder is my solution and my answer. So if I plug 2 in for x on that, my answer would actually just be 14. So all they're looking for there is what is g of 2? It'd be 14. And if I plug it in, write it all out. And if you're confused on number 5, I can help too. On number 5, it's kind of different. We're still using synthetic division, okay? Still using synthetic. Need to take attendance here. Let's see. Yes, we haven't gotten there, but you're exactly right. Exactly right. Excuse me. Exactly right. Is that a 0? The x minus 6, is it going to produce a 0? Good. Nice. Let's get to see Jess. Here's Paige. Here's Thomas, Caitlin, Savannah.
Whether you're looking for a quick, gluten-free snack or ingredients to make a balanced meal,
Cool.
Publix makes it easy to shop the products
Cool.
you need.
Done that.
Simply spot the wellness icons located on our shelf tags to help guide you to the better choice items, organics, and more that fit your lifestyle and health goals. Visit us online at publix.com/wellnessicons to learn more.
Hey, if you get to one that looks like this as you go through the homework, I'm going to give you a couple more minutes. I'm just kind of coming around and making sure you're getting it. We'll probably do one more and then we'll take a breather, okay? Y'all are seeming like you're picking it up fairly quickly, so we can go into the next one if need be, okay? Is anybody on number 5 over here? Y'all on number 5? Okay. Just as a heads up, just do A and B. Number 5 is a little different. I told them this, so I'll just kind of tell you all this. Number 5, you're still using synthetic with the number 2. Here's the one thing with the remainder theorem, which is what you're using. When you plug 2 in for your magic box into that synthetic division, whatever your remainder is your solution or your answer. So it'd be the same, like if I plug 2 in for x, whatever I would get out would be what I would get for the remainder. Does that make sense? So we're just using synthetic division, and then our remainder is our answer. Cool. Mary Gracie, that makes sense. No.
Is there?
You don't have to plug the 2 into the
So you actually would not, in this case, change the sign because they actually give you what the value is. You don't change the sign. This is the only case that it doesn't. Correct. Like right here, too. If they told me x equals 2 is a 0 on this polynomial, I'd actually just plug in 2. But if I say in parentheses it's x minus 2, that's when I change the sign. Cool.
But should we change it on this?
Say again.
Do we change it for this?
No, whatever you see, you actually plug that exact value in.
Is this right?
14 is it? Yes. So 14 is my answer.
Why do they keep on having tours?
I don't know. There should be 3 different families that were existing in the center, and I hate talking about it.
I love synthetic.
Subtract 2.
Oh, you'll just add right. You'll just add right down.
You get 3,100.
Wait. 12, 2, 4. Maybe I got it.
You're right, Kennedy.
What did I do? 6.
Yes, so what's your answer?
I did 6x.
Well, here's what I would do. You start with the remainder, right?
1, 0,
By itself, x squared, x third, x squared,
4x.
so it goes the remainder, and then the number by itself, right? So you're like 1, 3, 4, 5. So it actually would be 1 down.
So this is a number itself. Okay. Working over 2.
Not as much as I thought.
So it'd be actually 14 over x minus 2 because it like didn't give you the factor that's there. So what you got is this.
Is this right or hers? I'm so sorry. Hers is right. So I didn't know.
What's your remainder?
26. Yeah, mine is 14. Okay, she got you. No, she didn't.
Oh, 0 plus 2 or 0 plus 6. 6. I'm sorry, maybe I messed up when I saw yours. I saw the last number. So when I do this, it's actually you don't even have to write this out for this specific problem because with the remainder theorem, this means that I'm plugging 2 in for x, right? That's a lot of work. 2 to the 6, that's a lot. So what we're going to do is we're just going to say, okay, we did plug this in for x. The remainder theorem says whatever our remainder is our answer. So all that means is 14 will be my answer.
How do you know
Just the way that they wrote this, it's called G of 2. I haven't taught it yet out here, but people are starting to come to it, so I just kind of helped as we can. G of 2 just means
this is not the answer. It's just 14.
just 14.
And it's because it's in this form.
Correct. G of 2 just means if I plug 2 in for the equation, what would I get out? Does that make sense? Cool. Elijah, what we got? So this, do you get synthetic? Cool. So here's what we're gonna do, okay? This means if I plug, you're just gonna do A and B, by the way. That's it. Okay. If I plug 2 in for x, what would I get out?
No, you
Now,
don't.
that's a lot of work. 2 in, 2 times 6, that's a lot.
Yeah, you were.
So instead what we do is we're gonna put 2 in our box, okay? Don't change the sign on this one because I'm getting it to you. Then you're gonna put next to it the coefficients that are here, okay? So 1, 0 is x to the fifth, right? Negative 4, 3, 2, right? Or 3, 0, 2, okay? Then I'm gonna do synthetic with 2. Whatever my remainder is would be the solution if I did plug 2 in. So whatever my remainder is, like let's say it's 10, that would be the answer if I plug 2 in for x.
Whoa, what?
Does that make sense? Cool. How we doing, y'all? Paige, you good? So now you found H and K, right? So H and K you got, and then A is negative 3, right? You can just put A, H and K in the formula and you're good. Good work. Y'all doing okay over here?
Good shit.
We're ripping through this homework, y'all. Nicely done.
We can put a 0.
Grant, are you okay? Over there?
Yeah.
Cool. All right. Hey, could I do something? Could we pause where we're at right now? Y'all have been rolling on this, and so I've kind of allowed us to go a little bit further. We're going to do our character development here in a second. Let me give one quick problem to you. I think you already know how to do this, but I just want to make sure that you understand where we're headed. On this one, number 35 is just an example of this, okay? If I tell you that a 0 is 2, right? Do I change the sign of this when I actually put it in synthetic division? No. The difference with that is if I say on 39 that the factors of this are x plus 2 and x minus 1, in this case, I change the sign. You see the difference there? See the difference on that? Where I give you a 0 versus the actual factors. So if I were to go backwards here, and you were to look at 35, I would put 2 in my box, right? If I were to say find all of the other zeros, I would simply do synthetic. So 1, 0, -7, and 6. I'm not going to insult you. You know how to do synthetic, right? Bring down that 1, multiply, and then add, and then keep going, right? Because it gave me the fact that this was a solution, we should get a remainder of 0. And in this case, we do. So that means that 2, in fact, is a solution, right? Or an x-intercept, right? Question, though. What does that end up producing for me? This will be our last one. Let's be quick. X squared plus 2x minus 3. It's going to then ask you, what are the other solutions here? So what do I do to find the other solutions? I factor it, right? So I set this equal to 0, and I say, okay, what are the 2 other factors? And it would be what? Sorry? Good, yeah, good, Ellen. So x plus 3 and x minus 1. And when I set this equal to 0, the zeros would be -3, 1, and 2. Okay? And what's the multiplicity? What's the multiplicity of this? Good. And it's 1 for each, right? 1 for each. That's exactly right. Okay? How do y'all feel on that?
Good.
Y'all feel good? Awesome. Okay.
Can I sit in the rest here?
Yeah, come on. Come and sit. Okay, I'm gonna let me give a disclaimer for this. This is something that I have done for the last, I think it's been 3 or 4 years that I've done this. And I've done it since I've been teaching seniors. Has anyone seen this back here? It's kind of been hidden all year. Literally, this poster, I do this every year, and some people are like, I've never seen that poster in my life. But it actually has been here all year, just covered. So here's the thing. This poster right here, I created because of something that I found out called an ikigai. Okay? I think it's pretty cool. Basically, ikigai is a Japanese concept, means your purpose, it's your reason for being. Okay? I believe, based off my faith, that God uniquely made us differently. We talked about this year. And the fact that each of us have strengths and each of us has challenges and weaknesses that God allows us to have and has created us with to do a specific purpose. I believe that. Okay? I do believe that. Some of you may not believe that, but just with my what I think, man, I do. I believe you are uniquely made. Okay? So because of that, each of us are going to answer this differently. My whole thing for you is this. I found that this can be one of the most impactful character developments that we do all year. We're going to actually do it over the course of the next 4 weeks. So you're going to see different components each week, okay? I am going to give you a sheet that actually has it on here. You'll see that it's going to be divided up into 4 different sections, okay? And the sections that we're going to do, and you're going to see this here, correspond to different things about who you are. So the top one is, what do you love? We're going to answer that question today. And what I'd like for you to do is just right above it. I can't make you take this seriously, to be honest, but I would ask of you, hey, take this seriously. It can be very impactful especially as you put all 4 together, okay? I've found that some people have said this is the single best thing that we did this year, which I don't know how to feel about that, but I'll take that as a positive. So as we look at this, really focus in and dial in on making this serious with what we're doing. So what do you love? We'll talk about other things about what the world needs. We'll talk about that later on in another week. What can you get paid for? We'll talk about that. And what are you good at? Because that's actually a good thing to know. So what we're going to do is I'm going to give you one sheet right here. And you'll see it's going to be divided up like this. We're going to start with the top section. And what I'd like for you to do is answer the question up above, what do you love in that top category? And just in bullet points, specific to Savannah, to Kayla, to Thomas, to Elijah, all the way around, what do you specifically love? And it doesn't have to be, it could be anything, okay? And so I want you to put that down.
Are we listing like a list of things or just one thing?
Go put a couple things down on there, okay? Also, put your name on the back. I'm not going to look at these unless you want me to, but you're going to give these back to me, and so that way I can keep you having them from week to week, okay? So go ahead and write those down. While you're doing this, I'm going to show you a video of where Ikigai was actually created. This is not an English word. It's actually a Japanese word that that they actually talk about, and I thought it was pretty cool that they have this word that refers to their meaning for being, okay? The reason for living. So talk about this, or write on that real quick while you watch this video, and we'll check it out. Let's see if it comes up here.
Yeah.
That's not it.
What is AP?
Try this again. Today's Wednesday, right? Let's see. Earlier today. Look at this. May or may not come through. Let's see. All right, just write those down. What do you love? Write those down. I've got this link here. I just got to pull it up. Oh, there it is. Yeah, it's right there. It's different. Perfect. Hey, check it out. 2-minute video. Man, I thought this was pretty cool. Really was impactful for me. So check this out. We have to kind of read the subtitles.
沖縄には生きがいという言葉があります。毎朝起きる原動力を与えてくれるものだと思います。
目覚まし本当に遠くに投げ捨てようかなと思う時もあるんだけど、我慢して自分のお尻に鞭を打って起きて走りに行きます。
踊りの流部道場に通っている生徒たちの成長を見るために。
私の生きがいは、いつも馬に会いに行くために、仕事をしに行きながら、責任を持って人と馬とも接していっていますね。
お客さんがね、喜んでもらえたら一番欲しいんだけど。
いや、自分には兄弟もいないし、この孫たちがたくさんで、たまには孫たちが寄ってくるさね。もう本当これが生きがいである。
世界チャンピオンになりたいんだって、俺はなるんだって、家族のために、チームのために、自分自身のために、ということが生きがいですね。
家族があったり、友達がいたりいて、みんなに助けられて、こいつのために助けたいとか、それを苦にも思わずできたり、仕事も目標があって、それに対しての勉強や努力は全然疲れない。苦にならない現状のことじゃないですかね。一日楽しむために起きてます。
沖縄ではハッピー、毎日が、幸せであればそれで生きがい。
What do you think? Do you think there's a correlation between that last statement? Did you see that? I don't know if you saw that or not. Right here. See, right here. Okinawa, they live longer and happier. Many times people believe because they actually have this word, reason for being. If you went up and asked someone, hey, why do you do what you do? Like, what's your reason for being? They know the answer to that question, right? So this whole concept of ikigai, think there's something to it? Why do you wake up in the morning? What wakes you up? Your purpose. How many of you definitively know? Like you've thought about this? Like, yes, this is it. How many of you don't know? And that's okay. Usually 99% of people, yeah, that's a lot of people don't know. Well, this is what we're going to go through and walk through. This idea of ikigai. What do you love? What the world needs? What can you get paid for? Because that's important, right? That's important. And what you're good at. Those four things correspond and kind of come together to form what we call our ikigai, of your reason for being. And so as you write that there on your ikigai, would there be anyone brave enough to say, hey, this is today. What are some things that I love? This is what I put on what I love. Does anyone want to just share? Family? Okay, good. Anything else, Josh, or is that? Yeah? Very good. Very cool. Anything else? Anyone else?
Friends.
Friends? Okay. What did you say, Mary Grace? Friends? Very good. Is there anyone else?
Serving others.
That's awesome. That's awesome, right? Do you think there's something to that maybe in your future?
Yeah, for sure.
Very cool. Anyone else? Say again, Savannah. Nature. There you go. That's something you love. That's good. Very good. Anyone else? Grant, what'd you put? I'm curious.
I put 3 things.
Yeah.
I said people, learning, and creating.
That's great. That's perfect. Those that know Grant, is that true? I would say that's true. Good. Very good. Anyone else? Something to think about. What do you love? Do you know that the majority of people who work nowadays do not enjoy what they do? Do you know that? Do you know that? I think it was something crazy that now in this generation, and I'm talking me and then anywhere up, that on average someone will hold approximately, I think it was something like 14 jobs before they retire. That's crazy. Why do you think that people are bouncing around from job to job? Yeah, they're trying to do something that they love to do or find that. Any other reason you think? Money? Yeah, money's the motivator. Anything else? Boredom? Yes, this is true. Anything else? Any other reasons? I have a student, and I'll leave this person nameless, quite a while ago, came in my class, and we had an activity that wasn't an ikigai. I wasn't doing that at the time, but we were talking about our purpose and what they envisioned themselves doing, what did they really love. And this person loved kids, loved kids. And that's awesome. It's absolutely phenomenal. And so I said, that's great. You know, like, what are you going to go into that involves that? And they were really sad, and I said, what's up? I mean, I don't mean to put you on the spot, but is everything good? And they said, hey, I would love to go into elementary education, but my parents have told me it's not prestigious enough. It won't make enough money. Even though that's what I love to do, I can't do it because they won't pay for my education if I go in that route. And like my heart sank because I was like, man, how many people are in that same boat? Whether that individual couldn't do it or whatever, that's tough. So my whole thing is, man, whatever you choose to do as a senior, I'm talking to you like, not bigger than that. This is bigger than that. If I had one piece of advice, other than knowing Jesus Christ as your Lord and Savior, second to that would be, man, go into something that you love to do. Life is way too short to go into something that you hate or that you just want to do to make money. Money will not satisfy you. Because when you get it, guess what you want? You want more of it. Okay? That's because that's how we were designed. We want more of it. We want more of this and more of that. It won't satisfy you. You've got to go into something that you love to do. So if you're wondering right now, hey coach, I don't know what I'm going to major in, that's a normal conversation to have. That's normal. But I would say the best place to start, hey, what do you love to do? And identify that and be able to say, okay, this is what I love. Write these things down. What can I do to hit this, and this? Okay? Let me give you an example. Me, for my life, this is what I love to do. Say, coach, why? A couple of reasons. Number one, my number one love is Jesus Christ. My number two love is my family. And my number three love is being around y'all. And so it hits all three because I get to spend a ton of time with my family. Well, first of all, it's Jesus Christ because of the Christian school and how cool is it to talk about God all the time. Number two, being with family. As a teacher, I get to be with family all the time because I get to be around my daughter. She comes to games, got breaks. I mean, it is awesome. And then being around y'all, that's a great thing too. So thinking about what I love to do is very important for my purpose, for waking up in the morning. Cool. Does anyone have comments, questions, statements over that? I get passionate about that. I apologize if you felt like I preached at you. Here's what I want you to do. I want to build off this idea of what is my ikigai, and maybe after this activity, after 4 weeks, it's not like maybe you didn't get closer to it, but I want you to have this sheet as something to kind of hold on to help you as you go along and to reflect and to add to it. So I'd like to be able to use this over and over again. If you feel like you can hold on to it because you're pretty organized, go ahead and keep it. If you're like me and you're like, man, I probably will lose this thing, if you want to, I'll hold on to it for you. And that way we have it, and then I can continue to give it back to you from week to week. Just put your name on the back, and what we'll do is this. Put it face down here. Again, I'm not going to read these unless you say, Coach, could you look at mine? I'll look at it then. But this isn't for me. This is more for you than for me. And so go ahead and just stick them right here on this side. And we'll go from there. Cool. What do y'all think about doing this for a couple weeks? Is that okay? Cool. Oh, I'm sorry. Yes, go right ahead. I'm sorry. Yep. Yes. All right, timing wise, what do we got? All right, we've got 8 minutes. Okay. Could I do this? Could I hit on one minor topic and then we'll do a hot seat today? Is that cool? Who has not done the hot seat that wants to do it? Savannah? Savannah's going. Let's go. Let's go. I'm going to ask her about Disney. That's what I'm going to do. Ask her about Disney. Oh, it's TBD. You'll find out here in a second. TBD. Or no, that wouldn't be it. TBA? TBA? I don't think that is.
What are you trying to say?
We'll go with it. I have no idea. Like, wait, but anyway, yeah. To be continued. That's it. To be continued. TBC. All right. Hey, this idea, you got to understand like where we're headed, okay? Questions, and just shake your head. Just kind of give me some feedback. I won't point you out. Synthetic division. We're good on synthetic? Yes. We're good on synthetic? Okay. Ish? Okay. Long division. Progressing, I would say we're probably here. Okay. Probably need a little bit more. As far as the zeros go, remainder of zero, what that means that it's a solution. X-intercept. Did we get that? Yes. Cool. Okay. The podcast is going to be about 10 to 15 minutes. I'll keep it to that amount, okay? The podcast will not have questions that are off your homework. So technically, you could do the whole homework tonight if you wanted to, because all the questions that are on there, you are able to do. However, I need you to watch the podcast, take some notes on it, submit those notes for a homework grade, okay? Again, it will be quick. One of the concepts here is, what do I do to find the zeros of a polynomial? Let me get a different color here. Of a polynomial, if I do not know any of the zeros, okay? We'll talk about this concept more on the podcast. But what I need you to know is sometimes when I go here, I have this thing called the possible zeros, called the rational zero test, okay? We list the possible zeros that could come up within this polynomial. That doesn't mean it is. It means it's the possibility. It kind of narrows it down, okay? So how we do this is we do the values of P over the values of Q. You say, what, Coach, what are you talking about? Well, we take this idea of P over Q, and we take the last number, which is -3, and we take the first number, which is +1, and we put them over each other, okay? So it's the last over the first. If you think about it that way, it'll help, okay? The last over the first. Last over the first. Now, I'm not done yet, because in this instance, to list the possible zeros, to use what we call the rational zero test, we're going to list the factors of the top number. So what are the factors of 3? 1 and 3. Money. Okay? What are the factors of 1? 1, right? Plus or minus 1. Very good. Okay? Now, once I finish this, I'm going to then put 1 over each possible one that's here. Now, I know there's not a 2 here, but if there was a 2, it'd be 1 over 1, 1 over 2. 3 over 1, 3 over 2. Got me? It's all possible combinations. So when I put this over, we would say 1 over 1 would just be plus or minus 1, and 3 over 1 would be plus or minus 3. Okay? So you say, Coach, what are you talking about? These are the possible zeros of this polynomial. Okay? Now, on the podcast, we're headed here. If you don't get this, we're headed there. How could I test whether these are actually zeros of that polynomial? Synthetic division, and if the remainder was 0, right? If you don't quite get that, that's what the podcast is going to be over. I'll do 2 examples as the game plan, okay? All right, very good. Elijah, could I just test this one out with you with the last one? What's the P over Q going to be for this 46 here? That might be hard to see. My fault, man. See that there? So this is x to the third, and this is 16 on the outside. Good, except flip them, right? So it'd be 16, right? 16 over, and you don't have to take the x to the third, just take the coefficient, so it'd just be 1. Good. So what are the factors of 16? P over Q. Factors of 16 would be, and anybody could answer, 1, 4, 2, 8, and then 16 itself, right? And then it's all over what? 1, right? And now this is easy when it's 1. Whatever's on the top is going to be the possible zeros. So we would just list the top ones because it's all over 1, so it would just be the top possible zeros, okay? I'll hit that again on the podcast. I just wanted you to have just a little bit of that before we get to the podcast here. Savannah, come on up. Let's go. We've got 3 minutes. We're going to rapid fire questions at Savannah today. And Desert Island, 3 things or people. Who or what would you bring?
I would bring a sketchbook, a pencil, and probably my sister.
Very good.
Who's older? Are you sisters?
I am.
How many minutes or seconds?
10 minutes.
Wait,
2 minutes.
2 minutes. What about Disney? Tell us about your Disney trip.
We were there for Christmas. We had 4 days in the park, so we went to each, a different park each day. It was to celebrate our dad's graduation, but also our graduation.
Awesome. Very cool. Any other questions? Throw them out there. What's the show you're watching? Like your favorite show right now?
I'm watching New Girl right now, but my favorite show is probably Friends.
Gotcha. Who's your favorite character on New Girl?
Nick.
Nick? Gotcha. What do you think about Schmidt? Does he make you uncomfortable?
He reminds me of my cousin, which is kind of weird, so I kind of like him.
I gotcha. Very good. Very good. Any other questions?